2A concept is there, operating system concepts. Okay, so all these concepts that comes under your the main core concepts that some of the company they ask and focus on the in their interview and also in the online test. Okay, and means that if you are really interested to join any product based company and all, so in the interview mainly they ask those questions, means on core subjects. Okay, I think which are the subjects are covered? Anyone like a database? I think it is going, no, database is going on, COE is going on, operating system is also going on, computer network it is completed. Is my screen visible?
Yes, sir.
Okay, thank you. कंप्यूटर नेटवर्क और कौन सा है? DBMS. Okay, that is in the SQL also. I think it is in third year. System software, C programming, C++, and the Java. I think next semester maybe. Java this semester or next semester? Is there Java subject this time? Next semester. Okay.
Next semester, sir.
Okay. Then Python. Python it is no in this semester only. Python is in this semester. Okay. Then see, these are very important subjects for your placement. Okay. And in the gate syllabus, gate is also that contain the 15, I think 15 marks from aptitude, verbal and reasoning. 10 questions will be there. 10 questions, 15 marks. And I think here 45 questions, 50, some 45 questions you will get. Okay, 45, 60 marks, something. Means whatever the subjects I have mentioned here, so those subjects that covers in your gate. Okay, so that's why, and it will be like helpful for your placement also, placement and gate examination. Later you can check it out this. Later you can check the syllabus. Okay. So why I'm telling means it will be helpful for you people to revise and you can get it into any product based company. Okay. So in the last class we discussed about binary conversion. Okay. So today I 754 data representation and before that the normalization concepts. Okay. Normalization means you have to adjust the floating point, the decimal point you have to adjust. One example. So this one we discussed in the last class. In the floating point data representation, see such a large number. Okay, that you have to represent here. 10 raised to 23 is there. Such a large number we are represented in a form. In a which form? The floating point form. Okay. So for this floating point form, floating point format, floating point format. So this is the sign. One bit is reserved for the sign, and the next is for the exponent. Okay, sign, exponent, and significant. That is your fraction part. Okay, here you can see the decimal point. Okay, this is the format: sign, exponent, and significant. So that is the format of this particular IEEE 754 representation. And in the normalization, okay, in the normalization, we are shifting the adjusting the decimal point as already discussed by 254 into 10 raised to 0 means it is equivalent to 254. Even if I write 25.4 into 10 raised to 1, it is also means we are representing the in a data in a different form. 2.54 into 10 raised to 2. Here how many 2 after the decimal point 2 digits are there. So 2 10 raised to 2 it is equivalent to 254, right? This is very important. It is required in because why we are converting this normalization form means like to convert the decimal number to binary form. Decimal to binary form we require binary form. Okay, we require that normalization. Okay. Now there is one example. Okay. Here you need to represent this. This is in a normalized form. This particular number. Okay. Because in binary conversion no like binary conversion, one is division method, right? Suppose 10.15, this is decimal. So for this particular 10 integer part, so which method you are used to find the binary? Division method. Division method. And for the fraction part, which method? Multiplication method. Okay. So to convert this particular 10.15 from decimal to binary, okay, we are using both this method, division and multiplication. So that's why this multiplication, see here, multiplication means that's why we represent the number. Suppose this is a very small number, okay, like 0.254 into 10 raised to 3, right? Here I represented the same number in this normalized form 0.254 into 10 raised to 3. So why I represented this in this form? Because I have to convert into binary. A decimal form है ना, so that I have to convert into binary. So 0.254 into multiplication method, no. So that's why we have to represent the data in a normalized form. Okay. Now here you can see one example. Represent okay. Represent 0.254 into 10 raised to 3 in a normalized base 8. So base 8 means octal. Okay, you have to divide by 8. Base 8 floating point format with a sign bit followed by the a 3-bit XS4 exponent. Okay, followed by the 4 base 8 digit. Followed by the 4 base 8 digit. See, first they are given one decimal number 0.254 into 10 raised to 3 that you have to convert into base 8 format. Okay, with sign bit is there. You know the in floating point sign bit is there, exponent bit, then that significant bit, that is fraction part. Okay, so here what they are mentioned now, no, you don't think about this 3-bit access and followed by 4 base 8 digit. Okay, here first target is, what is your first target? First step is you have to convert into the target base. Okay, what is the target base? Base 8. Initially the number 0.254 into 10 raised to 3. This is the original number. That is decimal, right? And this decimal you have to convert into base 8. Base 8 means what? Octal number. base 8 is octal number. Okay, so you have to convert that 0.254 into octal form. Okay, so octal means what? So here into 10 raised to 3 is there. So here you will get this particular digit. Okay, 254. Means it is easy to convert this 254, that is division method. Here suppose if there is any minus 3 means that will be a problem. But here into 3 is there and we will get a complete integer form. Okay, so you can do by the division by 8 and you will get this particular form 376 to base 8. Okay, and once we got this particular base 8, that is our target, then represent in a this normalized form 8 raised to 3. First is you convert into target base. What is target base? Base 8. Second step में क्या करना है? Normalize. Normalize, you know already, shifting the decimal point. There is no difference here. 376 into 8 raised to 0. 8 raised to 0 means 1. Why you have taken 8? Our target is octal, right? Then the same it is represented in this form into 8 raised to 3. कुछ difference नहीं है. Both are same. Okay. So point this 376 is our target, means normalized form. और ये पर्टिकुलर डिजिट को हमको किस में रिप्रेजेंट करना है? दैट साइन exponent significant, that is the representation of your IEEE data representation. Okay, so yeah, means computer will understand this language, this binary form computer will understand. Okay, so how this form is generated? Second में normalize हो गया. Third में fill in the bit fields with a positive sign because 376 is a positive, right? So ये तो हो गया. So this is done. अभी एक्सपोनेंट में क्या क्या है? व्हाट इज द एक्सपोनेंट? कितने? 3 है. तो यहाँ क्या उन्होंने मेंशन किया है? इट इज फॉलोड बाय a 3-bit excess 4 exponent. In the problem statement they are given, okay, sign bit followed by a 3-bit excess 4 exponent. 3-bit excess 4 means excess 4. Excess 4 means you are required to add 4. Suppose excess 5 means you are required to add 5. Okay, तो हमारा एक्सपोनेंट कितना था? 3. और वहाँ प्रॉब्लम स्टेटमेंट में क्या मेंशन किया है? यू नीड टू ऐड एक्सेस 4. तो कितना हुआ? 3 + 4 7. So that is your this part excess 4. Here we are not any creating any new thing. अभी उन्होंने मेंशन किया है प्रॉब्लम स्टेटमेंट में कि you add excess 4 to the exponent. So exponent कितना है हमारा? 3 है, right? So to that particular exponent we are adding the excess 4. उसके बाद उन्होंने क्या किया है? Followed by the 4 base 8 4 base 8 digits. 4 means 4 digit, yeah, 4 digit fraction. अभी फ्रैक्शन कितना है हमारा? 3 डिजिट है, 0.376. तो उसके बाद एक जीरो ऐड करो, so that is a 4 digit fraction. Okay, and that same number it is represented. Okay, पॉइंट ये फ्रैक्शन है ना, फ्रैक्शन का ये बाइनरी पार्ट है. Okay, see here I will show you. Convert binary to decimal to binary 376. Only decimal value take. Fraction it won't take. Just I will erase. I will explain once again. I hope it is clear. Actually, the thing is that we are representing the data in a form that computer should understand. See, computer it won't understand the 376. Okay, it understand only the binary, the data in a binary form. Okay. So, any doubt here? See, I will explain once again. You know, the floating point means how we represent the data. Sign, exponent, then significant. Okay, means fraction part. A particular, this is the total format. Huh? Then now you have to represent this representation of this in a normalized base 8, normalized base 8 floating point format. Okay, base 8 means what? Octal. Okay, this is complete a problem statement they are given. Represent in a base 8 followed by the sign, means with a sign bit. So it is a positive number. So sign bit is always, it is a positive here. Then after that followed by 3-bit excess 4. 3-bit excess 4 exponent. So whatever the exponent we will get, okay, in that we have to add 4 value. It may be anything value like excess 1108, excess 105, whatever the excess value they mention, we need to add to the exponent, followed by 4 base 8 digits, means fraction per part कितना होना चाहिए, 4 digits होना चाहिए. Okay, so here with respect to this problem statement, what is our first step? Convert into target base. So what is the target base? Octal base 8. Okay, so they are given 0.253 into 10 raised to 3. ये उनका, this is original number. In 10 raised to 3 means क्या है? 10 raised to 3 means it is a decimal number, right? This is a decimal number. So this decimal number we need to convert into the base 8 form. Base 8 means क्या है? That is target is base 8 octal form. तो उस octal करने के लिए what you do? See here it is 10 raised to 3 is there. So here you can get 254. So 254 value octal के लिए divide by 8, binary के लिए divide by 2. Okay. So you can just find out the octal. Okay. 8 3s are 24. Then 8 2s are 16. No, 8 1. Okay. So कितना है remainder? 6. 8 3s are 24. Okay. So 3. Now bottom to up. So 3 7 6. ये क्या है? Base 8 octal है. Okay. Now you got your target value. Okay. So the next thing is what? You have to represent in a normalized form. 0.376 into 8 raised to 3. There is no difference. Huh? 376 it is equivalent to 0.376 into 8 raised to 3. There is no difference. Both are same. We are represented in a normalized form. क्यों? क्योंकि we are converting it into the binary. Okay. We are converting that number into the binary. Okay. So now we got here 376 that we are represented in a normalized form. Okay, now the next step is fill the bit fields with a positive sign as per the target. Target में उन्होंने क्या बोला था यहाँ? The format with a sign bit. Okay, so sign bit you know, positive followed by excess followed by 3 bit. कितने bit? 3 bit होना चाहिए. 3 bit excess 4. Excess 4 means exponent को 4 ऐड करना पड़ेगा. अभी हमारा हमारा ये क्या है? Exponent कितना है? 3. Exponent is 3. तो वो पर्टिकुलर एक्सपोनेंट को ना x4 ऐड करो, 3 इज आवर एक्सपोनेंट, वहां उन्होंने क्या मेंशन किया है, ऐड x4, तो 3 + 4 कितना हुआ, 7, 7 का बाइनरी कितना है, 3 बिट मेंशन किया ना वहां, 3 बिट, या 3 बिट x4 एक्सपोनेंट, 3 बिट x4 मीन्स आपको 3 बिट में रिप्रेजेंट करना पड़ेगा, ओके। देन फॉलोड बाय 4 डिजिट फ्रैक्शन, फ्रैक्शन पार्ट कितना है हमारा, कितने बिट है, 3 बिट है, तो उसको ना हमको 4 बिट करना पड़ेगा, हाउ, यू बाय एडिंग द जीरो, और ये 0.3760 इसका बाइनरी है दिस वन, this is the binary, okay. Now this is our result, so the computer will understand this binary language. This is the sign bit, this is the exponent part, and this is the fraction part, okay. So we are converted the original number, what is the original number, 254 into 10 raised to 3, 254 into 10 raised to 3, point, no, 0.254 into 10 raised to 3. So this decimal number into this particular the computer readable format, that is your readable format, means it computer deals with the binary data, okay. So any doubt regarding here, we'll discuss one more problem so that you will clear with the, now we discussed about base 8, okay, base 8 का discuss किया, अभी base 16 का discuss करेंगे, we will have one more problem here, okay. So if you have any questions, you can interrupt in the middle also, no problem. यहाँ क्या है, convert, yes, anyone tell what is the base form here? Okay, roll number 8. Can you just unmute roll number 8?
Yes, sir.
What's your name?
Nahin Bijapur, sir.
नहीं. अभी so now it is which form?
Decimal form.
Good, decimal form. So this decimal form you are converted. What is your target?
To scientific notation.
Means
Yes.
base to
Binary.
binary. Good, binary form. So now we have to convert decimal to binary. Okay, then see, this is our number. Original number is 9.375 into 10 raised to -2. So is this number equivalent to this number? Means how you convert this? How you eliminate to find the binary? ये 10 raised to -2 को आप क्या करते हो?
By shifting the decimal point on left hand side.
Left hand. Okay. So how many here -2 is there? So 2 digits.
Yes,
09375. Is it correct?
Yes, sir.
Okay. तो आपने ये क्यों किया आपने? Why you are done?
To remove the 10 raised to -2.
Yes, वो exponent, क्योंकि you are finding the binary. अभी कैसा decimal था, that you have to convert into binary. So this binary, this data 0.09375, how you convert into binary? Which method you use? Which
Decimal
method?
to decimal to binary conversion.
I mean for this fraction part is there, no? How you convert into binary? Which method? Division or multiplication?
For fractional part, multiplication.
Good. Okay. So अभी यहाँ हमने क्या कर रहे हैं? We are converting into we are using a multiplication method, and like you can take this particular fraction part, okay, then this particular fraction part and this particular fraction part, okay. So in this way you are performing this particular binary, okay. 0.75 into 2, so yeah, 0.5, yeah, 0.5 आता है. So what is our binary? It is from bottom to the top to bottom, right? Top to bottom.
Yes, sir.
तो वैल्यू कितना आया? 0 0 0 1 1. Okay, this is our result. This particular number. ओके इसका ये डेसिमल नंबर का बाइनरी कितना है? दिस इज द बाइनरी. ओके, so this you will get. Okay, now how you represent it in a normalized form? No.
By multiplying with 2 raised to power.
ओके, क्योंकि IEEE में क्या है, IEEE डेटा रिप्रेजेंटेशन में साइन, एक्सपोनेंट चाहिए एंड फ्रैक्शन पार्ट दैट इज सिग्निफिकेंट. तो यहाँ दिस पर्टिकुलर 0.00011, so this is equivalent to, here you can shift this 1 2 3 4. So here this particular, it is shifted here. Suppose if we shift to this particular form, बाइनरी का पहला कैसा ऑक्टल था हमने पहले एग्जांपल में. नाउ दिस पर्टिकुलर दिस बाइनरी यू आर शिफ्टिंग टू दिस प्लेस, कितने 4 बिट्स मूव किया आप, so that is equivalent to 1.1 into 2 raised to minus 4. Okay, so this 1.1 into 2 raised to minus 4, that is equivalent to, okay, into 2 raised to 0, or if you remove means, right. So this is equivalent to this. Yeah. So I think all of you clear with this. Okay. And now actually we got this binary form. That's why here we have to, in this particular normalize, we have to consider this one, means 1.1. यहाँ क्या होता है, this is your exponent. Exponent कितना हुआ? -4 है. Fraction part कितना है? 0.1. और this integer part is 1.1. Here 1 minute. Huh? 1 point. Here I will show some examples. Here, actually this is the way how we have to do the represent the data in a IEEE format. IEEE में क्या है? There are two types. One is single precision. Okay, this is very important. One is you will get MCQ questions. In single precision, it is a 32-bit single precision part. There are two types. Means it represents the data in 32-bit, and it represents the data in a 64-bit. 32-bit means what is the type? Single precision. 64 का type क्या है? It is a 64 is a double precision. Okay, it is a single precision floating point data representation. And 64 कौन सा है? 64 is a double precision floating point format. Okay, and this is standard format. We cannot change this format. ये 32 bit में one bit is reserved for the sign. Okay, one bit is reserved, means fixed है. One bit is for the sign. Sign में we have only two options, either positive or negative. So this particular, it is reserved for the sign. Then 8 bit for the fraction. 8 bit for the fraction. Remaining कितना हुआ? Sorry, 8 bit for the exponent. 8 bit for the exponent. 9 digits हो गए. Out of 9, out of 32, 9 bits reserved. One for sign and one for sign and 8 for the exponent. So 32 minus 9 means 23. So 23 bits for the fraction. 23 bit for the fraction. Okay, sign, exponent 8 bit and fraction 23 bit. So total कितना हुआ? Total it is a 32 bit. Okay, in this way we have to represent the data. Yes. Hello. हाँ हाँ बोले ना। Oh, okay, thank you. Okay. Okay, so single precision. So how many bits? 32 bit. And double precision कितना है? 64 bit. Or and the reservation for the 64 bit is 1 bit for the sign. Okay, 1 bit for the sign and exponent 11 bit plus 52 bit for the fraction. So 52, 63, 64. Okay. This you have to remember. Many times in the gate also they are asked how many bit is reserved for the exponent part. How many bit is reserved for the reserved in the for the exponent part. Okay. So gate में क्या आ सकता है? Like questions like for single precision floating point floating point format. Yes, roll number 8. नहीं ना, what is the that particular 32 bit form for 32 bit data का ये क्या है? Split 1 bit.
1 bit for sign,
हाँ,
8 bit for exponent,
okay, then
23 bit for specific.
that fraction part, that is a specific and or fraction. You can just consider it as the exponent and it is a fraction part. Fraction part is after the decimal point 23 bits are reserved, so total 32 bit. And similar to that, double precision के लिए for double precision floating point form, what is this one?
1 for sign, 11 for exponent.
हाँ, ये लो ना. So अभी सपोज हमको क्या है, ये आपने सिर्फ इतना ध्यान रखे तो हो जाता है. 1 plus 11, तो रिमेनिंग कितना हुआ?
52.
52 bit for the fraction part. So total 64 means we are representing a data in this particular form. The computer, अभी हम बोलते हैं ना, like our machine is a 32 bit machine, 64 bit machine. Okay, means why we call it this as a 32 bit machine, 64 bit machine means it performs the operation in 32 bit form, 64 bit form. Okay, so single precision IEEE standard. This is IEEE standard 754 floating point data representation. 32 bit means it represents in a 1 plus 8 plus 23 sign bit, exponent and fraction. So for double precision, sign, exponent and fraction. So that is 64 bit. So you should remember this is very important. So now here see some of the examples are there. You can see the example here. So see, this is the number, the value they are given. Whichever the value, आपको कौन सा भी फॉर्म में दो, suppose if they are given the in a decimal form, that you have to convert into this binary form. Here 2 raised to 5 is there, no? So 2 raised to 5 indicates what? 2 raised to 5 means it is a binary form. Okay, you have to convert into this form. Now for this particular value, what is the sign here? Sign क्या है? 0. Okay, then exponent कितना है? 5. Then this is the fraction. Okay, so here there is one more rule is there in IEEE 754 format. Okay, so this is already we know, like sign bit, Okay, sine, and here we call it as a exponent and also biased exponent. Biased exponent, and उसके बाद normalized mantissa और that fraction part. ओके, इन 32 बिट में क्या था? 32 बिट 1 8 प्लस 23, 1 बिट 8 बिट एक्सपोनेंट मेंटिसा और फ्रैक्शन और सिग्निफिकेंट. ओके, we will call it as मेंटिसा पार्ट और फ्रैक्शन पार्ट और सिग्निफिकेंट. ओके, so 1 plus 8 plus 23 for single precision है. ओके, yeah, this is one thing is here very important. This rule you have to note down. यहाँ क्या है? For single precision type, 1 bit for the sign. Biased exponent is for the reserved, 8 bit is reserved. 23 bit is reserved for the mantissa or fraction part. Okay. So यहाँ क्या है? Biased value, it is 127. Means यहाँ जो भी वैल्यू आता है 8, this 8 bit reserved no for exponent, ये पर्टिकुलर एक्सपोनेंट वैल्यू रहता है. ओके, एक्सपोनेंट वैल्यू, सपोज एक्सपोनेंट लाइक 2 रेज टू 7, व्हाट इज द वैल्यू? 7 है ना, ये 7 को ना 7 प्लस 127 ऐड करना है. it is a rule. Okay, for आइथरवेल डेटा रिप्रेजेंटेशन, बायस्ड एक्सपोनेंट मींस जो भी वैल्यू है, ओके, एक्सपोनेंट का जो भी वैल्यू आएगा, ओके, here it is exponent 7, no, 7 plus 127. Okay, 7 plus 127 ऐड करना. what is this 127? it is biased value. वैसे डबल प्रिसीजन के लिए क्या होता है? वट एवर द सपोज हियर 7 है एक्सपोनेंट, उसको क्या ऐड करना पड़ेगा? 1023. ओके, 1023 दैट यू हैव टू ऐड. ये सिर्फ कहाँ ऐड कर रहे हैं हम? एक्सपोनेंट वैल्यू को, सिर्फ एक्सपोनेंट इन द एक्सपोनेंट वैल्यू ओनली वी आर एडिंग. ओके, तो हियर अभी यहाँ जो है वैल्यू, ओके, अभी यहाँ कितना है? यस, नहीं ना, आर यू देयर?
Yes, sir.
हाँ, now what is the sign here for this particular ये? what is the sign?
Positive.
So positive means
0.
0, right?
0.
Okay, so exponent, in the exponent, what is the exponent value here?
5.
So 5. So 5 plus, see here we are representing in a 32 bit form. 32 bit का क्या होता है? Bias. 32 bit means single precision. Single precision means what is the bias value? 127.
4. 127.
So here 5 plus 127, how much?
132.
So 132 binary. So 132 binary value. So here, yeah. So here you see, I think you can, is it visible?
Yes, sir.
132. 5 का कितना है? 5 is, see, this is the 5, 101, right? 101 01 01. 127 का कितना है? Okay, so this is the binary value for the 1 27. Okay, 127. Okay, so 5 plus 127. This is 5, right? 127 means कितना है? 0 1 0 1 1 0 1 0 1 0 1. तो कितना आया? 1 4 टाइम्स 0 100. 1 4 times 0 100. So for single precision, what is the bias value? 124. And for double precision के लिए, see here, for this particular example, this is for the double precision floating point format. So double precision means क्या है? 1 bit for the sine, 11 bit for the exponent. तो exponent में हम क्या, या -128 प्लस 1023. ओके, 1023 माइनस 128, या जो भी वैल्यू रहता है, फॉर दैट वी आर एडिंग द 1023. एंड रिमेनिंग, या एक्सपोनेंट है ही नहीं, सो ऑल द रिमेनिंग द 52 बिट्स आर जीरो. ओके, so in this case, in this particular case, यहाँ देखो, यह फ्रैक्शन कितना है? 101. ओके, बट यहाँ टोटल फिल कितना आना चाहिए? 23 बिट, नो फ्रैक्शन. This is 1 bit, this is 8 bit, and here it is 23 bit. So after this fraction, after this particular part, no, 101, whatever the remaining value will be there, that is your fraction part. 101, and remaining we add it to all 0. Okay, so we'll have one more discussion. Abhi 85 point, here I'll take this one. Okay, yes, Nahina, are you there?
Yes, sir.
Now this is the our from the decimal value we got, this is the binary. Okay, 1 point, this visible, no, this value.
Yes, sir.
So 1.010101 some value is there into 2 raised to 6. So 2 raised to 6 means which form it is?
Binary.
Binary. Now you have to convert this into IEEE single precision 754. Single precision means 32 bit. Now what is the sign here?
Positive. 0.
Fine. Okay, sign is your 0. Okay, this is sign bit. Now in the exponent, what is the value?
6.
So what is the bias value you have to add here?
127.
Good, 127. So if we add the 127 biased exponent, we will get 133. Now for 133, what is the binary? So this is the binary for 133. Okay. Now I hope it is clear for the exponent. Exponent you are adding 127, and how much bit is reserved for the exponent?
8 bit.
8 bit. Okay, so this is the sign, and for 8 bit is reserved for the exponent. 133 का binary है 101. So here, so 133 का binary कितना है? 1 4 times 0 101. Now Now what is the fraction part?
Fraction part.
Here
0 1 0 1 0 1. 23 bit.
23 bit. 0 1 0 1 0 1 कितने डिजिट्स हो गए ये? 1 2 3 4 5 6 7 8 9 टोटल कितना आना चाहिए? 23 बिट.
23.
So 9 and how many remaining?
14.
14. So 14 digits. 1 2 3 4 1 2 3 4 8 12 13 14. So now 1 bit for the sign, 8 bit for exponent, 23 bit for the fraction. So this is totally how many digits? 32. So this is the IEEE 754 representation of a this given number. So इसका original क्या है? Means this one 85.125 is there, no? This you know how to convert the decimal to binary. Okay, and here you in the binary, no, you have to represent the normalization form in terms of like here. I say 1 point something. I say represent किया ना, then you can represent it in a proper format. Okay, so that's why I hope it is clear, a single precision format. So here you can see for this particular sign is 0, exponent, fraction. And here also in the second example you can see what is the sign. Yes, anyone? Yes, Naina. What is the second में क्या है? नेगेटिव है कि पॉजिटिव है?
Negative. Negative means 1.
1. और ये कितना है? एक्सपोनेंट माइनस
Minus 126.
तो माइनस 126 कितना ऐड करना है यहाँ?
1
एक्सपोनेंट
0.
127.
हाँ.
Whatever the value we have to add 127. तो कितना आ गया? 127 minus 1. So here you can see this one in binary form. How many bits are reserved? 8 bit. और fraction कितना है? How many digits?
5 digits.
0 1 0 1 1.
1 1.
So 23 minus 5 means our remaining 18 bits क्या रहना चाहिए? All are 0. But वो particular fraction 23 bit fill होना चाहिए.
Yes,
Okay.
sir.
Okay. Next, is there anyone? So can anyone others explain this one? ये particular C का कोई है क्या और? Anyone unmute? For C इसका ये क्या है? Sign. Anyone unmute? Anyone? It is not that much difficult. Sign का क्या है? Anyone? Row number 22. Row number 22. P. Row number 22. Are you there? Row number 2, 10. Anyone?
Yes, sir.
Row number
2.
2. So here what is the sign here?
Sign is positive. 0.
Positive. Okay. और एक्सपोनेंट कितना है?
127.
तो उसको कितना ऐड करते हो?
127.
गुड. तो 254 उसका ये है बाइनरी. और फ्रैक्शन कितना है?
127 bit.
नहीं फ्रैक्शन पार्ट. मेंटिसा फ्रैक्शन पार्ट कितना है? आफ्टर डेसिमल 0. तो 0 एक हो गया और रिमेनिंग ऑल आर 0. ओके. आपको कितना 23 बिट फिल करना है वैसे. So I hope it is clear. I hope it is clear for all to represent the number in a binary IEEE 754 representation. We'll discuss some. These are all some standard number, not a number. Not a number means here all are 1. Okay. Yeah, this one. Up to this it is clear. So here positive 0. So this is the binary. Positive 0 means here all are 0. here minus 0 means negative number. Negative we represent here 1 in terms of IEEE data representation. In plus infinity, here sign is, and here in plus infinity we represent here exponent part all are 1. Okay, even and here, and this NaN means what? Not a number. Okay, so this is not a number. NaN means not a number. NaN, that we represent in this form. Okay, so here we will discuss in the next class some example, so that you can just note down one example here. You represent this number, note down this number, minus 12.625, represent the number in a single precision IEEE 754 format. Note down, this is a part of your tutorial work. All of you note down this problem statement. Minus 12.625, take a snap. Okay, even I will post through the Google Classroom also. You just note down, you have to complete it by next class. आपको यहाँ क्या करना है, ये पर्टिकुलर नंबर डेसिमल में है, उसको बाइनरी कन्वर्ट करना है. ओके, बाइनरी कन्वर्ट करके so this form will come, and next you have to represent in a single precision. Single precision means how many bits? 32 bit. 1 exponent 23 fraction, right? So you represent it in a single precision format. So that is your homework. Okay, so okay, so is there any doubt?
Excuse me, sir.
Yes.
So how to identify whether the number is single precision or double precision?
Yeah, see, 32-bit number means single precision. No, means they will give in the problem statement like
Okay.
you convert the number, any number into single precision format. Single means 32-bit format. Okay, and they will mention like convert the number into double precision format. Double precision means 64-bit format. Normally in the examination they won't ask 64-bit. It takes some time, no? So in they may ask for the single precision to represent this number, because here अभी क्या है यहाँ -12.625, तो इसको आपको बाइनरी में कन्वर्ट करना पड़ेगा बाय मल्टीप्लिकेशन मेथड एंड बाय डिवीजन में. डिवीजन एंड मल्टीप्लिकेशन दोनों यूज करना पड़ेगा यहाँ बाइनरी कन्वर्ट करने के लिए. It takes some time, and that you have to represent it in this particular form: sign bit, exponent bit, and fraction part. So it is a total 32 bit. So in exam they particularly they ask whether you have to represent in single or double precision. It is like your machine. मशीन में क्या होता है, 32 bit machine, 64 bit machine means 32 bit data means it performs operation in a 32 bit. like आपका ये है ना माइक्रो प्रोसेसर, 8 bit microprocessor, 16 bit microprocessor, 32 bit microprocessor. Okay.
Okay, sir. Thank you.
Yeah, I will share. Okay, I will share in the Google Classroom. Okay, guys, we'll end the session. You can leave. You can leave if you don't have any questions.
Sir, can you share the class code for joining the classroom, sir?
Yeah, I'll share in the WhatsApp group. I'll share in the WhatsApp group.